This lesson is about sketching linear graphs, but this time using what's called the x and the y-intercept method. So, as the name suggests, what we need to do is find both the x-intercept, or where the line is going to cross the x-axis, and the y-intercept, where the line will cross the y-axis. So, for example, if we happen to draw a line that looks something like this, what we're trying to find is the value of this particular point there and this particular point there. What we do know for an x-intercept is obviously it's the point where the line or your graph crosses the x-axis, and the y value is always equal to 0. So in order to find an x-intercept, what you can often do is let y equal 0 and solve for x. Opposite with the y-intercept is that obviously what we're going to do this time, it's where the x value is equal to 0, so we often let the x equal 0 and we solve for y, and obviously we're referring to that particular point there. To show you an example, the question says sketch the following graph using the intercepts. So what I want to do first of all is state the following: let x-intercept, we're going to find that, so we're going to let our y value be equal to 0. Notice how in these graphs we don't actually need to put it in standard form. So we let y equal 0. So what happens is it becomes 2 multiplied by 0. So you can see at the top of the equation there was 2y. So instead of 0, it just becomes 2y becomes 0. Subtract 3x equals 12. What happens with the 2y? Basically crosses off. All I'm left with is minus 3x equals 12. X becomes 12 divided by minus 3. X is equal to negative 4. Because at the coordinate point, it's negative 4 and 0 being on the x-intercept. So I go across to negative 4 and 0, and there it is there. So I label it as negative 4 and 0. Next point, y-intercept. Let x equal 0. So you see the working out that I'm doing. And what happens in this instance, before I run out of room, minus 3 times 0 equals 12. So the equation 2y minus 3x equals 12 becomes 2y minus 3 lots of 0 equals 12. We know that disappears. So 2y is 12. Y is 12 divided by 2. Y is 6, or as a point form, this time it's 0, 6, which is up here on the y-axis, 0, 6. I then simply get my line, my ruler, and that's not really close, so I'll try and move it. Oh, hang on, bear with me whilst I try and move things. No, not going to work. But as you can see, what I'm trying to do is put the red line on the 4 and the negative 4 and the 6. Second graph. Looking at this graph, it's in standard form, so I could have used the gradient and the y-intercept, but instead I've been told I have to use the intercept method. So I need my x-intercept. I let y equal 0. So the equation now becomes, instead of y equals, 0 equals minus 2x plus 6. I now solve this one for x. Take that adding 6 to the other side, it becomes a minus 6 equals minus 2x. Divide my minus 6 by minus 2 to give me positive 3 for our x value, or 3, 0. Go across there, mark it in of 3, 0. Y-intercept. Well, good thing with y-intercept, I can let x equal 0 in this instance, but because it's in standard form, I can see straight away that my y-intercept is actually going to be equal to 6, or 0, 6. So I can then go and plot the point up here of 0, 6, get my ruler out, and rule the line. Again, reasonably close, but not too bad. One thing I forgot to do on the last graph that I need to always do is go back and label the equation y equals minus 2x plus 6. So I do need to write on there what the actual graph was. So sketching graphs using the intercept methods. Some little rules. All I need to do is I need to find my y-intercept by letting x equals 0 and solving for y. and find my x-intercept by letting y equals 0 and solving for x. Once I've got them, put them on the graph and rule my line that goes through those 2 points. That's exercise 5.7. So good luck with questions 5.7. Don't forget to be using pearsonplaces.com.au to help give you some hints for some of the other questions. Good luck with this one.